Tiny computer, big potential. Introducing Arduino Uno. Arduino Uno is like a tiny computer you can program. It's great for controlling LEDs, sensors, and other small electronics. But there's a catch. Arduino Uno can't handle high voltage or current directly. This means we need extra components to work with powerful devices like motors or high-brightness LEDs. Don't worry, this essay will guide you through controlling high voltage with Arduino Uno safely and effectively. We'll explore components like relays, transistors, and MOSFETs, and learn how to wire them correctly. By the end of this journey, you'll be able to control a range of high-voltage devices, opening up a world of exciting project possibilities. Get ready to unleash the full potential of your Arduino Uno. Beyond the limits, why relays are essential for high current. Arduino Uno's output pins are limited. They can handle a maximum of 20 milliamps, which is enough for small LEDs but not for high current devices. This is where relays come in. Relays act as electrical switches controlled by low voltage signals from your Arduino. Think of a relay as a remote control for a light switch. You press a button on the remote and it closes a circuit inside the relay, turning on the light. This way, your Arduino can control powerful devices without directly handling the high current. Relays are perfect for controlling AC appliances like lamps or motors. They provide complete electrical isolation between the Arduino and the high voltage circuit, ensuring safety. Relay basics. Understanding the workhorse of high voltage control. A relay consists of an electromagnet, a spring-loaded armature, and a set of electrical contacts. When current flows through the electromagnet, it generates a magnetic field. This field attracts the armature, which closes the contacts, completing the high-voltage circuit. Relays come in various types and sizes, each suited for specific applications. For example, a single-pole, single-throw relay has a single contact that closes when energized, while a double-pole, double-throw relay has two sets of contacts that can be switched independently. Choosing the right relay depends on your project's requirements. Consider factors like the operating voltage, current rating, and the number of contacts needed. Transistors and MOSFETs. Unleashing the power of semiconductor switching. While relays are great for on-off control, sometimes we need more precise control over voltage and current. This is where transistors and MOSFETs come into play. These semiconductor devices act like electronically controlled valves, regulating the flow of current through them. Transistors come in two main types, NPN and PNP. NPN transistors turn on when a positive voltage is applied to their base pin, while PNP transistors require a negative voltage. MOSFETs are similar but offer higher efficiency and can handle more current. By varying the voltage or current applied to the base or gate pin of these devices, we can precisely control the amount of current flowing through them, enabling applications like LED dimming and motor speed control. Section 5. Solid-state control advantages and applications of transistors and MOSFETs. Transistors and MOSFETs offer several advantages over relays. They are smaller, faster, quieter, and more energy efficient. They are ideal for applications requiring precise control, high switching speeds, or silent operation. For example, you can use a transistor to create a simple LED dimmer circuit. By varying the voltage applied to the transistor's base pin, you can control the brightness of the LED. Similarly, MOSFETs are commonly used in motor control circuits, allowing you to adjust the motor's speed smoothly. However, unlike relays, transistors and MOSFETs don't provide complete electrical isolation. Therefore, it's crucial to understand their limitations and take appropriate safety precautions when working with them. Section 6. Wiring for safety. Essential tips for high-voltage projects. Working with high voltage demands meticulous attention to wiring. Improper connections can lead to short circuits, component damage, or even electric shock. Always double-check your connections and ensure proper insulation. Use appropriate wire gauges for the current being handled. Thicker wires have lower resistance and can carry more current safely. Use stranded wire for connections that might experience vibration, as solid core wire can break under stress. Color-coding your wires can help you keep track of connections and prevent mistakes. Use red wire for positive connections, black for negative connections, and green or bare wire for ground. Section 7. Safety first, always precautions for working with high voltage. Safety should be your utmost priority when dealing with high voltage. Always disconnect the power supply before making or changing any connections. Never touch live wires, even if you think they are not carrying current. Use insulated tools and wear safety glasses to protect yourself from electrical shocks and arc flashes. Keep a fire extinguisher nearby in case of any mishaps. Remember, electricity is invisible and can be deadly. If you are unsure about any aspect of your project, consult with a qualified electrician before proceeding. Your safety is paramount. Section 8. Real-world applications. Putting your skills to work. With the knowledge you've gained, you can now explore a wide range of real-world applications. Control high-power LEDs for stage lighting, build a garage door opener, or create a system to automatically water your plants. You can even combine these techniques with other Arduino sensors and modules to create sophisticated projects. For example, use a temperature sensor to control a fan's speed or a light sensor to automatically turn on lights when it gets dark. The possibilities are endless. Let your imagination run wild and use your newfound skills to bring your creative ideas to life. Section 9. Mastering High Voltage, a recap and final thoughts. In this essay, we've explored the fascinating world of controlling high voltage with Arduino Uno. We learned about relays, transistors, and MOSFETs and how to use them safely and effectively. Remember, safety should always be your top priority when working with electricity. Double-check your wiring, use appropriate safety gear, and never hesitate to seek help if needed. With careful planning, attention to detail, and a healthy dose of respect for electricity, you can unleash the full potential of your Arduino Uno and embark on exciting high-voltage adventures.